Welcome to another deep dive on the Primary Science Podcast. So today we are stepping into year 4 and year 5 materials. We're going to keep it super practical. So kind of by the end of this episode, you should have a page full of ideas that you can take straight into the classroom. And I must say, I've once again managed to assemble a proper dream team for this one. So first up, I'm very, very excited to introduce the wonderful Alex Farah, back again for a second round on the Primary Science Podcast. And also, I just wanted to mention on the side, very proud to say, she is my amazing Primary Science Quality Mark Hub leader. So Alex, would you be able to just tell everyone a little bit about yourself and what you've been up to recently?
Of course. Well, I'm a pretty seasoned science lead. I've led science in both primary schools and secondary schools in lots of different parts of the UK for quite a few decades. But of course, I am very much enjoying at the moment being your PSQM hub leader, as well as hub leaders to many other schools in not just different parts of the UK, but also across the world in 3 different continents at the moment. I'm also working as one of the PSQM development leads at the moment. We are always developing and improving the Primary Science Quality Mark programme, and we're working at the moment on a new leadership development option, lots of different opportunities for professional learning. So I'm really excited to be part of that team working on that as part of the PSQM community. So that's what I'm up to at the moment.
It's just a pleasure to have you back on the show. So I would also like to introduce our second esteemed guest today, which is Tina Whittaker. So Tina, I just wonder if you could tell us a little bit about what your role is in the world of primary science.
Lovely, and thank you for having me in this podcast. So Alex, like you, I have many decades of experience in primary science education. In fact, sometimes I'm even referred to as the wise owl. As long as I never become the Eeyore, I'll be okay. My focus is very, very much on school improvement and leadership impact, and not doing things for the sake of doing them, but knowing what is needed to make a difference to children, and especially those children that are not thriving. So I particularly love being in classrooms when I can be the eyes, ears, voice of the children and reflect back how what they are hearing is not necessarily what the teachers think they are teaching. So my favourite one is to talk about question asking. And the teacher will often say to a child, "That's a good question." And then I go to the child and say, "What was good about that question?" And unfortunately, the children often do not know what is good about their question. So, Tim, I'm looking forward to finding out whether your questions are good ones or not. Let's go for it.
That's brilliant. Yeah. Well, lovely to have you with us. I do hope my questions don't disappoint. And I'm very much looking forward to hearing all of your insights as well into materials. And then completing our trio today, we have the fantastic Kate Sutton. So Kate, we would just love to know a little bit more about you.
Hello, yeah, I'm absolutely thrilled to be here. Thank you so much for inviting me. I've been a primary teacher for 13 years and have a primary science specialism. I'm a chartered science teacher and I'm also PSQM hub lead since 2018. As well as teaching in school all that time, I've worked at the STEM Learning Centre in York as a primary secondee last year and also done some work this year at Surrey at the University of Manchester as a specialist project officer. I've got a real passion for all things STEM and engineering and careers related as a result of a master's that I did, completed in 2020. The benefits of that, having careers, science, careers information, it's so important in helping our pupils to develop their skills, problem solving, garnering attitudes required in life, like resilience and determination through learning science. And I also really value being part of the Association for Science Education community, and teaching, which, as I say, I've been doing all these years and been in year 4 for the last few years.
Oh, amazing. Thank you so much, Kate. And it is really a pleasure to have you with us. And that completes the dream team, everyone. So I think we need to get straight to business now. So year 4, we're talking solids, liquids, and gases. Some might say a classic unit, but also one where you might lose the kids quite quickly if you're not careful. So that's what we're going to try and bring out today. So Alex, I'll come to you first. Let's imagine unit's just begun. First lesson, what are you doing to switch those minds on straight away?
Yeah, I think it's a great start to have all sorts of different objects made from a real range of materials for the pupils to explore the sort of materials they may come across in the unit. They might include different liquids, might be water or salty water or squash. There might be all sorts of different solids. That might include ice, it might include sand or sugar or a wooden block, maybe even a balloon of air. And really, this would be, for a quick starter, to find out the sort of vocabulary that they might use, the sort of prior learning that they might have. They'd need to choose any 3 of the objects and then sort them out, which one is the odd one out and why. And that would be useful to listen to the conversations, to see what sort of vocabulary they were using, and really tease out those sort of observable properties like fragile or rigid or heavy or it will pour or we can stir it, whatever the words might be. Now, some of the pupils might use the word solid or liquid, and if they did, then that would be really useful to spotlight and change the activity a little bit to ask them to use those words in their sorting. But being really clear in your questioning, really clear in the vocabulary that you're using as a teacher, and thinking about which is the object, which is the material, what sort of properties it has, why it might be suitable for certain uses. That learning that they have done before, can they remember it? Are they using the vocabulary in the right way, or is it being used in the wrong way? So finding out what sort of base you're starting with. In this topic, they will be thinking a lot about different temperatures and different volumes. So a great practical activity to entice them into thinking or knowing that this is going to be a really hands-on topic and a really interesting topic would be to get them working on those skills of how do you find out how hot something is? How do you find out what temperature it is? What about volume? Can you use thermometers? Can you use different measuring containers? And thinking about how you can take readings, how you can record readings. What are the ways of using these thermometers or containers incorrectly? What are the ways of using it correctly? Thinking about scales, thinking about, are we all getting the same results or not? And one activity that I like to use to really get thinking going as well is the PSTT resource I Can Explain. And it's got a series of cards and pupils are asked to put them in an order of cold to hot or hot to cold. And that prompts a lot of conversation, a lot of use of vocabulary. Certainly does with teachers as well when you ask teachers to do it. But is the moon hot or cold? What sort of temperature is your bath water? What sort of temperature is lava, for example? All those types of questions perhaps have got different answers from different people. So that's the sort of way that I would kick off this topic.
Thank you. Nice. And that makes sense because you're getting the actual materials and then you see what the children already know, that prior learning. I wanted to just extend that question a little bit, because a lot of the time on this podcast and when speaking to the experts, such as yourselves, we always say that it's good practice to make things really relevant to the children. Why do we need to know about solids, liquids, and gases and what they are? Do you agree that this is something we might need to tackle right here in the starter? Or is it something that develops naturally throughout the lesson? Or is it maybe not something we need to focus on for now?
Yeah, I think we always need to focus on making it relevant and making the start point their interests and their experiences. And I think that this topic has a lot of possibility for linking it to their interests and experiences. There's opportunity for that to happen in all of the lessons in this topic.
Okay. So it's a focus, but just try and get it in right at the beginning if we can. Kate, I'll come to you next. What are the activities or investigations that you think really help the children to understand those states themselves, the solid, liquid, gas, and then how those interchange between each other?
Yeah, well, building on what Alex has just said, I totally agree. It's so important for them to begin to understand the properties, first of all, of solids, liquids, and gases, and then be able to compare and group those. A really good idea for an activity, actually, I saw in the Irk Academy lessons, and it was filling balloons. One with solid, one with liquid, and one with gas, and getting the children to look at those to help them to decipher the different properties. And I thought that was a really interesting idea for them to be able to build on their learning in that regard. Solids and liquids, not as tricky as gases, which at all teachers we know that teaching about gases to children is much more difficult. It's much more of an abstract concept, and helping children to realise that it's not just nothing and that it's taking up space, and making sure that we link that with secure, observable understanding tied to everyday life, as we've just said. It's so important so they can understand the relevance of what they're learning. Something that's really worked well at school, and as a PSQM hub lead I've seen working well, is where children use drama to act out. When they get those illustrations of the different molecular structure, and they can act out those different solid, liquids and gases, and even to the extent of one teacher I spoke to would have the children and tell them a particular temperature, and then the children would think in a group about how they would move dependent on what the temperature was for that particular material. Other things, we can link to breathing. We all need to breathe. So that's a great example. And talking to the children about us, the intake of gas, mainly oxygen, and the release of carbon dioxide, looking at kettles boiling, when we pump tyres, our weather, gases, and literally all around. And it's really good for us to highlight those real examples. Then in our series of lessons, we would focus on changing states from solids to liquids, or liquids to solids, as an easier thing to focus on first. Water is a commonly used example, and then pupils do plan using common materials and investigating melting points, then plan an activity, do and review, and often use things like chocolate, butter, cheese, and they really love that, being able to get hands-on and investigate with them. Something that I have really noticed, and Alex did touch on it actually, is it's so important to make sure that the working scientifically skills are there, and supporting children, if not to be able to understand and access the lessons in that way, because they don't always have the measuring and the being able to use data loggers, recording and representing straight away, and need help and practice to be able to use those skills. So that's something that is really important. Then we would build on that, thinking about liquid to gas. Really good that in year 4 they learn about the water cycle. So that's a really good cross-curricular link. And I found children really love, you can access raps and songs on YouTube that are really catchy, that help them to remember those different elements, for them to help them be able to go ahead and internalise and learn about it. Also, another part of the sequence is about evaporation, And I think something as simple as observing a puddle and drawing around that and then going back at intervals and observing to see that the rainwater evaporates can be really important and informative and interesting for children. Diagrams, as I've said, are often very abstract and hard for pupils to understand easily. So getting hands-on and in their locality is a really good way to do that. And just some top tips, things like Explorify. They've got loads of really great examples and activities that teachers can use to help with starters or within the lessons. Also BBC Bite Size. Concept cartoons are also a really helpful way of getting the children thinking and talking about their ideas. Oak Academy, as I mentioned, and PSTT. Their Seashore Science book has loads of great ideas if you can get your children to the coast. Luckily, I work in Bridlington, so we can get beach trips and really think about it in a really hands-on way.
Yeah, so many ideas there. And again, a lot of those built on the idea that this science is already part of their lives, right? The puddles in the playground, it's already right there. And before we move on, I did just hear you mention Oak Academy there, and that's not something I've heard of before. Could you just quickly tell us a bit about what that is?
Yeah. So Oak Academy was set up during COVID to support teachers in the classroom, and there are all different lessons, subjects available. And I particularly know about the science, the primary science lessons, and there are some really good elements that you teachers might want to cherry pick. I think things like that, where it's different schemes or different things that are already all set up. I think as a teacher, if you're less confident, you might want to use more of it. But as you build your confidence, you might be able to pick the elements of it that you think would really work for your setting or work within what you're doing in school to be able to enhance what you're teaching to the children.
Interesting. Okay, thank you very much, Kate. Now, I do just want to pause here for just a moment because there's quite an interesting discussion sitting underneath all of this that we've been talking about so far. So I would love to go over to Tina now. So Tina, the idea of particles in primary science, I wonder if you'd just be happy to share your perspective on this idea of teaching particle theory in year 4.
Well, this is really interesting, and a bit of professional discourse never does anybody any harm. So I'm going to present a professional ponder, and I'm doing it from a chemist's point of view. My degree qualification is chemistry. I absolutely disagree that we should be teaching particles in year 4. It is conceptually extremely demanding. There's nothing concrete about teaching particles apart from the fact that you're running around on a concrete playground. And I think that because we've always done it, we always do it, but we're not actually questioning whether there is understanding. So yes, children can redraw those drawings, but really we should be challenging that use of those diagrams for reasoning. And you've given me a chance, Tim. So I'm going to come at this from quite an academic level in terms of chemistry. So as a chemist, I challenge all primary teachers to consider the most common material that they are using in their lessons. And Kate has already mentioned water several times. So let's look at water then as a solid, let's look at water as a liquid, and let's look at it as a gas. According to the particulate model theory, ice would be much more dense than liquid. And yet it floats. Now, we show children that ice is floating. We do with the iceberg in the Titanic. So therefore, I have evidence that they're not using the particulate model to reason. Otherwise, they'd be raising questions about why that doesn't fit the model. And it doesn't fit the model. Water behaves completely differently. Now, I'm not going to take up the rest of the podcast by talking about hydrogen bonding. I think I did hydrogen bonding in my A-level. But my professional ponder is, can we be careful about what we actually need to teach so that the children have got those blocks, those concrete blocks to build on in their future curriculum?
I really appreciate that you've brought that up, because I do think it raises a bigger question in general in primary science and other subjects about the role of using models altogether. They are by design or by definition just a model, right? They're not perfect. It does make sense that we need to be careful about how we use them, or we might be introducing misconceptions ourselves accidentally. Even if we step away from particles in general, we're still trying to help the children to explain to some extent, right, what's happening rather than just describing what's happening. So I'd be really interested to know, if we're not going to lean towards the particle theory model, is there another way to support the children to explain to some extent what they're seeing with the solids, liquids, and gases? Or maybe do you think it's not necessary to explain at this stage? Or is that a good question?
I will give you that is an interesting question. And actually, I think the provocation is good. I think those are the conversations primary teachers should be having. How would we introduce this so as not to cause misconceptions? And all the way through my chemistry journey, it was understanding that this is only good enough. And next year, you'll find out that what I've told you is actually not really that true. But the idea that you're sharing with the children, this is a good enough explanation at the moment. And it could be a little bit like marbles. Do not mention the word particles, because particles mean something. It is the particulate theory.
And then Alex, I would love to hear from you next. How about if we look more specifically with something like evaporation and condensation, which, as Kate already mentioned, is part of the water cycle that we teach in year 4. What can we do to sort of bring this idea to life and make sure the students are following best practice as they go through investigations here?
Yeah, absolutely. And as you've already said, Tina and Kate have said as well, there's a lot of vocabulary in this topic. There are a lot of skills as well that need to be explicitly taught and also practiced. And there's a lot of concepts that can lead to an awful lot of confusion. Evaporation, condensation, what do they mean? What is going on there? So one example that I think is quite an interesting one is wet hands on black sugar paper dries up really quickly. And you can see that in just a short period of time, but also it leads to a lot of potential confusion. Where has that water gone? Has it been absorbed into the black paper, or has it gone somewhere else? Has it evaporated? So I think we need to think about the examples, not necessarily decide to not use them because they might be confusing, but to be aware of potential confusions. Kate mentioned earlier about puddles and marking on a puddle and seeing the size of the puddle change over time, which I think is a great example. In a similar way to that, you could take jugs of water and pupils could read the initial volumes of the water and decide where to place them. There could be one placed outside, maybe one on a windowsill, maybe one in a fridge or in a cupboard, and the pupils could predict if the volumes were going to change, how much they might change by, and then record how they were going to record, measure, and then record that change in volume, and to think about where has that water gone? Why has the volume decreased in one of those jugs more than in one of the other jugs, for example? And that where has the water gone, it could be useful to have slightly confusing ones, like the wet hands on black paper, but it could also be ones that may be a bit less confusing. So say, for example, a damp, wrung out flannel or piece of material hung on a classroom washing line, how long does it take to dry out? How can you find out how long it takes to dry out? How will you record that? How will you measure that? And where has the water actually gone? Certainly in some areas of the world, all coming in from a wet playtime might very much steam up the windows of the classroom. And what is happening there? Have you seen that steaming up of windows, as we might in English language call it? Though perhaps, is that the right term to use, is an interesting thing to ask. But that steaming up of windows in a bus or a car, which might not happen depending on where you are in the world. But what is happening there? Have you ever written your name on a window? And how have you managed to do that? You could use a kettle near a window to achieve that as well. One thing that works quite well is to have a small plastic bag with some water in it and sellotape it onto a sunny window, and then you can have that there for a period of time so that pupils can observe what is happening in that bag and why that bag is getting steamy, prompting conversations about evaporation and condensation. So I think it's about opportunities to talk, opportunities to observe, as well as measure, so that you're practicing those skills, but to use those words and to be challenged to use the vocabulary in the topic.
Would you ever put those sealed bags maybe on a display or somewhere outside the classroom for the children to talk with other students about? Would that be a good opportunity there? Or?
I certainly love it when pupils challenge me and make me change perhaps my plans. So a fair few years ago, we had every group having a little bag and sellotaping it to the window. And then, of course, somebody said, we really shouldn't be using so many plastic bags. Why don't we just have one? Is there another way we could do it? And of course, they were completely right. And we shouldn't have been rather extravagantly using one plastic bag for every group. So finding different ways and asking the class to think of different ways we could do that, or different places we could do that. What were we trying to achieve? What were we trying to look at?
Thank you, Alex. And I would like to move on to Year 5 now. Of course, loads more opportunities for practical investigations. And I'd love to go over to Tina. If you had to kick this unit off with one sort of strong investigation around properties of materials, what are you going for?
Well, your question used the phrase kick off. So I wonder if this was a good question or not, because I do seem to be the contentious one here today. Although as Wise Owl, I get to do that. I don't think we are kicking off this topic. I think one of the biggest challenges with Year 5 properties and materials is ensuring progression. There is so much prior learning in this curriculum that if we have to be really specific and careful not to repeat. So Year 1 and 2 have already had lots of opportunities for testing materials. Year 3 used the idea of properties to sort and group rocks, and they considered transparency and the light topic, along with electrical conductivity and the electric topic. So we're not kicking off at all, we're actually connecting. So I would actually start with real objects, so it's conceptual. It's in front of them, you put away all the particulate theory, and you're starting with real stuff. And making the point that it's the difference between the object and the material. So I would start with observations, and I would get them to build a bank of word properties, but I would add to those properties the opposites. So if they have done conductivity, what's the opposite? If they've done magnetic, what's the opposite? So you have this harvest of key vocab that you have already used, and in Year 5 you're going to be using that vocab. So I would now start to use a problem-solving approach within the investigation. Which properties for which function mean which is the best material? So this idea of fit for purpose. And my focus within the investigation would be on communicating their findings. How much do they trust the results? Will they get a causal relationship that's an authentic one? And if we can focus on that scientific bit of understanding, that becomes immediately relevant to their lives and citizenship. Because how many adverts do we see in a day? And what are those adverts claiming about that material? So how do you question that evidence? So I think the emphasis within this investigation is communicating your findings. But you did ask me for a favourite. Over all these years, which is my go-to? What do I often have in the boot of my car when I run sessions? And my go-to is to turn up with a metal flask with ice cubes in it. And I talk about my clinking metal flask and that these ice cubes have been in there for hours. So I'm actually getting that causal association of metal and ice. So I'm getting them to build a constructed relationship in their heads because I'm going to challenge it. My favourite bit of teaching is what I call the R moment, when the jaw drops and it isn't what they were expecting. That's the point at which they have to reconstruct all their thinking, and their explanation then has to build on new ideas. So going back to this metal flask, we then talk about needing a surface to melt the ice as quickly as possible. And we've got two surfaces, and because I think resources for primary should be easy to grab, I use spoons, a metal spoon and a wooden spoon. It could be baking trays with a chopping board, but something that's readily available but different materials. And then I set it in a context, and we're having a panic, extra guests have turned up, I've got chicken to defrost. What's going to be the quickest way to defrost it? Children think wood is warm. They think the wood will defrost quickly. The actual investigation happens so quickly, the difference is so dramatic, you just leave them rethinking. That surprise moment is special.
Yeah, that's really good. You're getting something counterintuitive, making them think. Also, I just wanted to say as well, I don't feel that your contentions are argumentative at all. I actually think it's just that you're being precise about protecting that progression and that we're not just repeating the same thing again and again. I think next it would make sense to go on to another important property that can cause some confusion as well, which is solubility. So if I could go over to Kate now, what does a really, solid, excuse the pun, dissolving investigation look like for you?
Yeah, it's a really interesting one, isn't it, solubility? Because pupils often think, they have the misconception that it's disappeared, when in fact dissolving is something breaking into tiny pieces, which we can't see. And a really good way to get over that is that if you dissolve brown sugar, it dissolves, but the solution is left with a kind of a tinting of colour. So it helps the children to realise that even though they can't see the sugar anymore, it helps them to understand that it's dissolved instead of just disappearing. I found that's a really helpful one to use. And also evaporating to show the salt crystals after they've been dissolved is a winner, and another one of those where the children gasp because although they saw the salt go in and a solution arrive, they're still kind of surprised when you can reverse that. So, and I've just literally done this in the last few days. So, don't want to spill it all over. You probably can't see, but yeah, they're absolutely enamoured when the salt or whatever it is that was in the solution reappears.
Thank you very much, Kate. I wanted to follow on there as well, something that immediately came to mind from a practical standpoint there. Have you got any tips on how we could let the children take part in that and do that safely? You know, i.e. when they're evaporating the water, unless it's waiting over a long period for it to evaporate in the sun, is there a way we could let them add heat safely and do it themselves?
What I would say with everything that we've talked about really and in primary science is always to refer to CLEAPS and to the ASE Be Safe to make sure that whatever it is that you're doing is the safe option. Obviously surface area helps. So with these, it's just like a small dish and we just put a small amount of water in and put them on the windowsills. And it was amazing really just with sunlight coming onto these, how quickly we got the result. At primary level, we don't have a lot of actually getting heat as you would perhaps at secondary.
I think sunshine gets the better crystals because slow evaporation leads to better crystals. So certainly on a windowsill is the go-to method, really. I know that some people do it in tinfoil cups and might have the, as you say, Kate, the CLEAPS method of heating with a sand tray and a tea light and tinfoil cups to get more of a heat from below. But I think that you get better crystals if you've let the water evaporate in the sunshine or in the shade so that it's over a long period of time. And that's quite an interesting one as well. Should they be in the sun or the shade? And in the shade, will the water evaporate or not?
And also getting the microscopes out is really brilliant for the children. You know, they love being able to observe really closely. Fascinating to see something in a different context under a lens.
I was going to add in, I think the challenge is that we're talking about evaporating water and therefore how can we get more heat to make it happen quickly. I think if we're linking this topic to everyday lives, then it should be in the windowsill. The puddle does disappear because of the temperatures around us in the daytime. But if we're trying to show evaporation quicker, maybe we think about another liquid and we squirt a little bit of perfume on ourselves. It's safe, it's in a perfume bottle, you can buy it in a local shop. But actually, I don't have to put my hand on anything hot to evaporate the solvent from my perfume. So I think the solution isn't about what do we heat with, it's what else might evaporate at a lower temperature. And we are at risk of bringing in the misconception that you need hot temperatures to evaporate.
Yeah, you could maybe show them a range of things to show them how different things evaporate at different temperatures. Okay.
And the only challenge there is returning back to CLEAPS because some solvents you would not want to be evaporating and having gases
only safe choices
in the room. So because water is your easy, safe go-to, it then presents us with these problems because of its points. But actually we can consult and come up with some safe solutions, but make sure they are safe.
Thank you. Okay. Now, next, we can start to talk about perhaps recovering a substance from a solution, kind of like what we've just been speaking about here. I wonder if, Alex, we could go over to you. How would you make this clear without overcomplicating it?
Yeah, I think that recovering a substance from a solution is definitely my favourite activity in Year 5, because of course when you make a mixture or you've made a solution, it is reversible. You are going to be able to get the different parts of that mixture back. And that's something that there are many, many examples of that pupils can relate to, that they will have experienced when they will have seen getting the parts of a mixture back, or recovering a substance from a solution. So say, for example, draining rice or draining pasta, they will have experienced one of the ways to recover a substance from a mixture, which would be sieving in that case. So again, some of the vocabulary and the different vocabulary for separating those mixtures, it is difficult. Whether it's sieving, whether it's filtering, is it evaporating, which is the most appropriate to do. So certainly modelling how to use a filter. Is the filter the same as a sieve? Is a sieve the same as a colander? All those different words, and looking at the size of the holes. So the size of the holes in a filter paper, or a sieve that's got much bigger holes with a colander, and which would be the best way to approach, say, for example, getting the mud out of muddy water, so that your water would be much cleaner. And one thing that I like to do is to have a mixture of paper clips and twigs and mud and salty water, and ask pupils to plan, first of all, how are they going to, as simply as possible, get all of those different parts out of the mixture. And of course, you've said in as simple a way as possible. If you've put a whole range of different materials, different resources available to them, and they're busy planning how they're going to do it, of course, you can imagine that they're going to think, well, we must use the magnets that are helpfully available to them to get the paper clips out. Now, of course, actually, you could pick the paper clips out, which might be an easier way of doing it. So I think it's always good to leave a choice of resources and let pupils stumble up against problems and solutions and better ways of doing things, so that they can have those conversations and perhaps fail a little bit, things go wrong a little bit, and then figure out the way of how they can correct it. In that particular example, they often very successfully separate out many of the different parts, but end up with salty water instead of water. And then they've got to think about how they could get the salt out, and they may then end up losing the water entirely. So it seems simple to start off with, but there's lots of things to think about. And there's a really good practical action STEM challenge about cleaning dirty water called Ditch the Dirt, and that's got some really good ideas. Of course, it may well lead to the example we were just talking about recovering salt from salt water and growing crystals, which is another favourite of mine. But certainly cleaning dirty water has got a lot of different elements to it.
Okay. And you've just mentioned another resource which sounds pretty cool there, the Practical Action STEM Challenges.
Quite a few different ones, and they are aimed at ages 8 to 13. So some of them would be more appropriate for Key Stage 3. But they've all got a very much a real life application and examples from different areas of the world. So say, for example, in that Ditch the Dirt challenge, they end up having large plastic bottles that are placed on black plastic, so that the large plastic bottles of water get really hot, and the bacteria in the water is destroyed. So it's got some examples of where in the world that is used to clean water to make it more possible to be used in, say, for example, cooking. So those STEM challenges have got slides, they've got recommendations for resourcing, recommendations for how you might use them, really good for teamwork, really good for some of those different skills that we were mentioning earlier. One of my favourites is the squashed tomato challenge, which I would very much recommend.
Nice. Thank you. And now we move into actually changing materials, where, of course, there are plenty more chances for proper hands-on science. Kate, how would you like to begin this portion or continue this portion of the unit?
Yes, so separating mixtures, really important to ensure that pupils know and understand how to use the resources, as Alex has just mentioned, to ensure that they understand what funnels are, filter paper, and not assume that they've had access to these things, because it's not always the case that the children can automatically just use all the resources that we get out. So by recalling and building on previous learning and connecting to previous learning, as Tina mentioned, the pupil should then be able to go ahead and separate the materials. And there's one lesson where they're given something, and it is called alien soup. And through the various means that, as Alex has discussed, they can go ahead and separate all the different materials. They really enjoy the lesson. It's really hands-on. And gosh, it's so important, isn't it, for the kids to be hands-on when they're learning. Before I became science lead, I think I'd forgotten that. And then through lots of different CPD and things, started to understand the importance of having the children being able to get hands-on. And to be able to do that, it's really important to develop teacher confidence, which is why things like what we're doing today, I think, are so important. And for teachers in science, we're so lucky there's such a lot of excellent CPD and excellent different resources that teachers can access to help them. And also, as we've mentioned, using real examples, even things like a tea bag, if you think about it, work really well in helping children to understand why this is so important for them to learn.
I love the sound of alien soup. Thank you there, Kate. Now, next, according to the curriculum, we also need to address changes that are reversible and irreversible. So, Tina, I wonder if you could let us know what you find works really well here.
One of my favourite pieces of kit is my popcorn maker. You can count the kernels in, and you can count them as they're coming out. And it's really easy to see what were the inputs, what were the outputs. You haven't got to worry about a chemical equation, what's combining with what. It's one thing in, but it's a different thing when it comes out. And when they've all come out, you can look inside the machine and see that there's nothing there. So this idea of actually the amount of stuff and the amount of stuff hasn't changed, but you've got a new material. And it starts lots of conversation about how you know it's a new material. What has changed? What are the variables that have changed? The volume's changed, the shape's changed, the smell's changed, and you can't get it back. So I prefer this language about a new material. If you start talking about whether it's irreversible or reversible and you get too hung up on that, sometimes it's just very difficult to reverse it. But if something new has been made, then it's absolutely impossible. So irreversible, new materials. I think for children, we should encourage them to focus on how can we show that a new material has been made? What evidence do we gather? So I think we could very much use the classic vinegar and bicarb here. But actually the challenge to the children is how do we know something new has been made in that reaction? How are they going to gather that data? And yes, you would possibly go to the classic glove or the balloon, but you might encourage them to think about how they might actually measure the amount of gas that's being produced. So again, it's that gathering data, questioning your data, observing with accuracy and systematic recordings. I do have another tip from the worldly wise owl. Many schools, when they're doing melting as a reversible change, they use brown chocolate buttons and they melt and turn into liquid brown chocolate and so on. I'm going to give you the tip of lard. When it's a solid, it's white. When it's a liquid, it's no longer white. It's not solid and it's not opaque. Oh, and now what happens when it cools again? So there's not many substances when we melt them that actually look different. They're just a different state. But lard does look different, but then does change back to how it started. So my tip of the day is to buy some lard. Alex provoked me to think about my plastic bag use, because my kit for melting is all in the little penny bags that are sealed, that you can then place into a warm water bowl. And I have had those little penny bags for over 20 years. So I think that fully justifies the use of those small bags. It makes a consumable non-consumable.
Wow. I'd have to say, though, plastic bags that last 20 years, that's
Fully
value for
justified.
money. They don't make them like that anymore.
But you are
Okay.
only using them to put it in the warm water and then take them out again, because you can see the difference made.
Yeah.
So many
Okay.
tips.
Thank you there, Tina. Great tip. And moving on, in the non-statutory guidance now, it also suggests that we can make links to industry, to careers, things like the materials for glue, for sticky notes, or looking at the invention of wrinkle-free cotton, so you don't have to do as much ironing. And this is where we sort of bring it all together. We could bring it all together and show the children why it matters, why we're doing this, or how we could apply it. Is there a way that we could perhaps practically weave this kind of thing into our lessons throughout the unit?
Yeah, I mean, I've given this quite a lot of thought, because I think some of the links that we make very enthusiastically as teachers, certainly myself included, perhaps linking to space travel, or maybe cleaning water if you were to happen to found yourself stranded on a desert island, or maybe even with the excellent example of alien soup, or maybe an industry in a totally different country to the one that you are living in, would be rather outside of the likely experience of our pupils, and trying to think about what will they actually encounter. Will they actually be stranded on a desert island and need to clean the water? So I've thought quite a lot about that, and tried to find ways to link activities while still retaining the really good activities, but linking them to their actual experiences. And one thing that I've found in the Year 5 materials topic is linking to their class reading book, because they're all reading that every day. So it's very much in their experiences. And one of the books that Year 5 were reading was Coming to England, the Floella Benjamin book about coming to England. And there's a part in the book, and actually there's many references to materials and changes in materials in the book. But one part of the book, they make ice cream. And that was a really good link to make to the materials topic. And certainly, I think, astonished us all how readily you could make ice cream. I must say, again, using a plastic bag, but making sure that we reused it, 2 plastic bags, in fact. A really good hands-on activity, linking to solids and liquids, linking to temperatures, linking to all the key vocabulary. And because it linked very directly to making ice cream in the book that they were reading every day, it was very much, perhaps not their direct experience, but something they were certainly thinking about a lot. So that was very successful. Another great link was when I asked pupils about the sorts of glue that they used at home. And I thought they might be saying things like Pritt stick or glues that I had heard of. And one pupil said that she used sugar glue. And I must admit, I had never come across sugar glue at all. So we were able to make some sugar glue up and then test it and compare its strength to the strength of post-it notes and test a few different glues. The PSTT resource Standing on the Shoulders of Giants has got a great glue investigation that includes some information about post-it note invention, but it also includes about medical glues that have been made from slug slime, the trails that slugs leave behind them, and how that slug slime is used in medical glues to stitch back together or seal back together a wound. That was also unexpected. So the sugar glue unexpected example from a pupil in the class led to a greater range of unexpected discoveries. And the glue, even though the slug slime glue was perhaps outside of their experiences, lots of them had had wounds glued together in A&E. So that was a way to link the topic to their own experiences.
I would definitely encourage children to be material vocab spotters. Try to catch their parents out. Try to catch the television out. Make sure people are using the words correctly. You know, we hear this word elements being used. Do we really mean elements? Can children create some questions that they can ask at home? So by the children creating the questions they're going to be asking, the children are predicting the misconception. So they might ask a parent, did that sugar just melt in the tea? Ha ha, Mum, no it didn't melt, 'cause it doesn't melt, and so forth. Is there more sugar dissolved in pop or tomato sauce? How might we find out? What is happening in that lava lamp? Do you think it's on fire? Does it look like it's burning? Oh, it's reversible. What about hand warmers when you're going to the football? What about the fish food? Is that dissolving? Is some of it dissolving? Custard, and so on and so on. I mean, one that challenges many teachers is jelly melting or dissolving when you make it. So we started off by saying the challenge is that actually there's much prior knowledge, and the additional knowledge that we need to add in this unit is making sure that that knowledge is not misused. And I think that is the problem. This topic is everywhere. It is every day, but it's used inaccurately. If, however, your original question was about encouraging children to be excited for their future lives, jobs, careers, then smart materials are absolutely at the cutting edge of innovation. But let me give you an example, a real one. And yes, I am going to be talking on this podcast about my latest manicure. I recently had nail varnish put on that changed colour depending on temperature. So if I was swimming in the sea, you could see that I was very cold because my nails were changing colour. I thought this was scientifically just fascinating. But if we take the fact that we now have a substance that can change colour with temperature, what uses might that have? And the children can get really creative with medical situations. Maybe some patients should have their toenails painted. You've only got to walk down the ward and check the toenails to know if that person's temperature is okay. What about babies' tools for feeding, etc.? Is it that we have a colour changing? So you start with, we now have a material that can. What are the uses that we could put that to? So just being alert and aware of that innovation is really exciting.
Thank you, Tina. And how about yourself, Kate?
Yes, well, as somebody that's got a really deep interest in primary careers, I think linking to careers for pupils is really important so they can see the relevance of what they're learning and why they're learning it in relation to their lives now and going forward. So, for example, when we were talking about solids, liquids and gases, the idea in baking that the process when you add yeast to something and you leave it to rise, there's a chemical reaction going on which causes the dough to rise so that we can have delicious bread. And then, being able to understand that in a bit more detail. Thinking about the things we've talked about in relation to engineering, things like blacksmiths, metal workers, the weather. There are so many different elements. Well, science is everywhere, isn't it, all the time? But the things we're talking about, there are so many different elements where they are really relevant, and it really engages children when they understand that. And I think Alex mentioned about standing on the shoulders of giants. There's some brilliant activities in there that teachers can use as well to be able to do this. Also things like linking to climate issues and climate control, greenhouse gases, recycling we've talked about as well quite a bit today. They're all really relevant to us now and will certainly be really relevant to children going forward. So a really good way to be able to link to those things to give them some more knowledge and information about those as well.
Excellent. Thank you. And wow, we've covered so much ground today for this unit, and I feel we've covered almost every base. However, there's always room for some more, especially when I've got three amazing experts right in front of me. So I will certainly not be wasting this opportunity. In addition to all that's been said, do you have any final golden nugget pieces of advice for this particular unit?
Yeah, I think mine would be to really try to make links to their own lives, to their own experiences as far as is possible. And certainly, as we've mentioned already, drawing a diagram of the water cycle in their books and colouring it in, or drawing diagrams of particles, just because that's always happened in this topic, doesn't mean that that is building the right skills or making the right links or getting them to use the right vocabulary. So an example of that for me would be an activity called glitter litter. Glitter is something that I certainly don't like to use in my lessons. I'm not much of a glitter person, but not for a plastic pollution problem reason. It would be more just I don't like glitter. But I'm embarrassed to say that I hadn't actually thought beyond me not liking glitter. I hadn't actually thought about where glitter goes and that it gets washed away and that it ends up in the ocean and it ends up as plastic pollution. And I am slightly embarrassed to say that I hadn't actually thought about that until I looked at the Saving the Planet One Lesson at a Time by Amy Strachan. And that's got this great activity, fits in really well with Year 5 and separating mixtures. They're challenged to make filtration devices out of recyclable materials and to stop glitter getting washed down sinks, and for them to really think about alternatives to glitter and what else could be used as glitter. Really great practical activity, teamwork activity, which gives lots of opportunity for thinking about the key vocabulary and the ideas in this topic. So I think I'd say try to link it to their own experiences, but also try to not do necessarily just the same that has been done in previous years, but benefit from resources that might challenge not just the pupils, but challenge the thinking of the teachers as well a little bit more.
Thank you. And Tina?
Well, actually, Alex, you just fed that beautifully, because I'm going to give a shout out for the Royal Society of Chemistry, who do so much good stuff for schools. It will provide you with those new ideas, that knowledge and understanding, particularly for non-specialists. So it's not just about the wow, it's about the science too. but take some time to look at their resources. If you simply search for steps into science, you can increase that range of ideas without leaning just on us. You can develop further.
Thank you. And Kate?
Yeah, some further really great resources which I'd recommend. We've already mentioned loads, and they're so helpful for teachers who might be feeling a bit stuck with some of these areas that we've talked about. There's a really great book, PSTT book, called Explore, Engage, Extend by Tracy Tyrrell, which is brilliant for pre and post assessment activities. It covers all of them, but obviously we're talking about these today. Also, the Great Science Share for Schools website and Engineering Educates. They've got excellent activities in there which link to what we've just been talking about today. Maker Futures, who are based at the University of Sheffield, loads of work to do with materials and making things from materials and recycling. That's really excellent. And the STEM Learning website, which has got so many things on there to support teachers in a very broad way when teaching Key Stage 2 materials.
And there we go, everybody. States, properties, and changes of materials. And I would say that's more than mission completed with all that we've learned and challenged today. And I have to say, it really is a bit of an understatement, to be honest, to say that I am so grateful to you all, Alex, Tina, and Kate. I want to say thank you so much for so generously bringing your expertise to us and giving us at the same time absolute gold to take to the classrooms and make a difference for the students, which is what it's all about. And as always, thanks to all of you out there for listening. And we'll see you next time on the Primary Science Podcast. Bye, everyone.
Bye-bye.
Thank you.